sketch the graph of y equals negative secant of 1/3 x. So the first thing to remember when we're graphing this is we're going to be graphing starting with y equals negative cosine of 1/3 x. So we look over here in our table, and to find the period, we are going to do 2 pi divided by 1/3, which is 2 pi times 3, 6 pi. And let's just label right now before we forget. 1, 2, 3, 4. Here's 6 pi. Didn't show up very well. I'm going to try one more time. 6. Vertical displacement. We did not move the graph up or down. But we do have a reflection. We have a reflection over the x-axis because of that negative in front of the function. We do not have a phase shift. But in terms of our domain, remember it's going to be for all reals such that x doesn't equal something times n, where n is, and we need to decide if it's just an integer or if it's an odd integer. And then we're going to have our range as well. But let's go back now that we've got the basics here. We're going to graph our cosine function. And normally with cosine, we would start at 1. But because we're reflecting over the x-axis, we're going to start at negative 1. 1, 2, 3, 4. We're going to finish at negative 1. So we went below 1, so we have to go above 1. And then our 2 mid values. But remember, our 2 mid values are where our asymptotes are going to be. Wherever we have the 0. So we're going to have an asymptote here. We're going to have an asymptote there. And in fact, now that we've got the pattern, we can put in all of the asymptotes here, here. Again, once we get the pattern, we've got the picture. Now we have our asymptotes in there. And what we have is, we have this. There's one period. Here's the start of the next period. And we can go the other direction. So there's 3 periods of the graph. And that should be enough for us to identify what we need to on here. But we do need to figure out, well, where are the asymptotes? And the thing is, at 1, 2, 3, 4, there's 6 pi, which means that this is 3 pi, which means that this is 3 pi over 2. And when we fill this in, this is going to be 3 pi over 2n. Well, 3 pi over 2, as I write this below here, this is 3 pi over 2. Then the next one would be 6 pi over 2. And the next asymptote would be 9 pi over 2. Then 12 pi over 2. And so forth. We could keep going with those, but where we have the asymptotes, we have the asymptotes here and here. And in fact, if I went one more, then it would be 15 pi over 2. That would be another place where there's an asymptote there, even though I can't get it labeled right underneath. So this is 3 pi over 2 times 1. And this is 3 pi over 2 times 3. and this is 3 pi over 2 times 5, the numbers that I'm specifically looking at here to determine the rest of my domain is that x doesn't equal 3 pi over 2 n, where n is an odd integer. And lastly, in terms of our range, we go from negative infinity to negative 1, and we're going to join that with 1 to infinity. Sketch the graph of y equals cosecant of negative pi over 2x minus 1. Remember, as we get ready to draw this picture here, we're going to be graphing y equals sine of negative pi over 2x minus 1. So a couple things that we can fill in over here. Our period is going to be 2 pi divided by pi over 2, which is 2 pi times 2 over pi, which is 4. Our vertical displacement, we've got a minus 1 at the end. We're going to go down 1, and in fact, I'm going to put in a highlighted mark right now because I don't want to forget it. So here's our down 1. Reflection. The reflection inside the function, which is going to be over the y-axis. We don't have a phase shift. Our domain is going to be for all real numbers such that x doesn't equal something n, where n is, again, we're either going to have all integers or odd integers. And then our range we're going to have to wait and see as well. So remember, now we filled in the box here, we're going to graph the sine, and what happens here is we're going to start here. And then 1, 2, 3, 4, I better label my graph here, which is at 4. And then the middle value, and then we would go up here, and we would go down there. And there's our sine graph, but don't forget that we reflected this graph over the y-axis. So this point, which I'm going to put in red here, is really going to land right there. And this point here, in red now, is going to be here. And in fact, I can put in this. And it gets jumbled up here in my picture because I don't need this point anymore. And I don't need this point anymore. My 4 didn't show up very well. This is supposed to be a 4 right there. So as I take a look at this again, I'm going to have an asymptote at here. I'm going to have an asymptote here. I'm going to have an asymptote here. I'm going to have an asymptote here. And in fact, we can keep going in this graph. And now I can get the picture because we're going to have a value here and a value here. And remember, then we copy the pattern. So value here and a value here. And there at least gets us 2 periods on our graph. And then let's fill in the rest of this. You can't see these values very well. That's 4, so my first positive asymptote is at 2. X doesn't equal 2n. And then where n is? Well, 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is 6. It's just going to be an integer. And our range goes from negative infinity to negative 2. And then we're going to go from 0 to infinity.